right, welcome to the deep dive. Today we're getting into physics that, it sounds like something straight out of science fiction.
It really does.
We're looking at the 2024 Fuchs et al. Paper on warp drives, and our mission today is to figure out how this idea went from, a mathematical fantasy to a genuine engineering problem.
Yeah, for what, almost 30 years, the entire field was just stuck. It was locked down by Albert Alcubierre's 1994 solution.
Which was elegant, but it had that one huge catch.
Exactly. The catch was exotic matter.
Yeah.
You needed stuff with negative energy density. And that, well, it breaks one of the most fundamental rules we have, the weak energy condition, or WEC.
Right, and if you violate the WEC, you get into all sorts of trouble. Causality violations, unstable vacuums. It just doesn't work in our universe.
It was a dead end. Beautiful math, but impossible physics.
So the field was trapped. But this Fuchs paper, it's a breakthrough because it's the first rigorous solution that works with the WEC. It only requires positive normal energy.
It does.
So how did they pull that off? They had to completely rethink how the bubble works.
No, it did. They basically threw out that classic surfboard idea, space expanding behind you and contracting in front.
It's the part that needs the exotic matter.
That's it. Instead, they focused on creating this incredibly intense momentum flux.
Okay.
They do it with a physical shell of matter, a really dense one. And it's all about managing something called the shift vector.
So it's not stretching space anymore. It's more like dragging it.
Exactly. Think of it less like surfing and more like a huge, powerful smoke ring made of gravity that flows around the ship.
A gravitational current.
Yeah, and that current just drags the flat, calm space-time inside it along for the ride, like a conveyor belt.
And because you're not warping space so violently, you don't need negative energy. You satisfy the WEC.
You've got it.
Okay, but this is where it gets really interesting, because the universe never gives you a free lunch. If the solution is now physical, what's the catch? What are the new constraints?
And they are, let's say, humbling. First, to make it all work with positive energy, the drive is strictly subliminal.
Slower than light.
Slower than light. So $5 CO, it's still incredibly fast. It's high-velocity relativistic transport, but no faster than light travel.
Wait, okay, hold on. If we give up FTL, isn't this just a really, really complicated rocket? Why build all this just to go 99% the speed of light?
That's the trade-off.
Yeah.
And it gets even wilder when you look at the other numbers. The mass, for example.
Oh, boy.
For just a small 10-meter ship, the shell of matter you need would have to be more massive than 2 Jupiters.
2 Jupiter masses.
Yep. And you can't just have that floating around. It has to be compressed to a density greater than a neutron star.
Wow. Okay. So we traded the theoretical impossibility of negative energy for the engineering impossibility of building a hollow neutron star.
It's less of an engineering challenge and more of a cosmic one at this point. And to make it worse, the paper only describes the bubble coasting.
It doesn't even have an engine.
No propulsion mechanism. You'd still need some other way to get 2 Jupiters worth of mass moving at near light speed.
So given all of that, why is this so important? Is there any practical benefit at all?
There is one. And it's huge. It's called geodesic transport.
And what does that mean for the passengers inside?
It means no G-forces. None. The crew would just be floating in 0 G inside the bubble.
Even if the ship is accelerating like crazy.
Exactly. The shell outside could be pulling insane maneuvers, but the people inside wouldn't feel a thing. No one gets turned into jelly. That is the holy grail for high-speed travel.
That alone is a revolution. And, the way they found this is also a big deal. It wasn't just pen and paper math.
No. It relied heavily on a new open-source toolkit called Warp Factory. It lets researchers actually compute and test these things numerically. It's a whole new way of exploring general relativity.
So connecting this to the bigger picture, then?
Well, it gives us a real concrete target for SETI, the search for extraterrestrial intelligence.
How so?
If an advanced civilization actually built one of these, a Fuchs-class drive, it would produce a detectable signal. You'd see these unique gravitational wakes or strange lensing anomalies moving across the sky at relativistic speeds.
So we finally know what kind of gravitational technosignatures to look for.
We do.
It feels like this validates that search. And here's a final thought for you to chew on. If the engineering is this massive, if you need the mass of planets and the density of neutron stars, what if nature is already doing it?
What do you...
Could some weird, high-density celestial object, like a strange binary system or a magnetar, be naturally creating one of these subliminal warp bubbles? Could one be hiding out there in plain sight and we just don't know what we're looking at?
Huh, that's a good question.
Something to mull on until our next deep dive.